Hi, I'm Aslı. For question 1, A, represent the minimum edit distance between A1 to AK and B1 to BL by a function name. I'm determining a method name. I set it to min edit distance because our goal is to find minimum edit distance. And for B, the function computes the minimum edit distance between str1 and str2, where the minimum edit distance represents the number of mismatches in their alignment. str1, the first input string represents the characters a1, a2, and to n, an. str2, second input string, representing characters b1 to bm. So this is, and for C, in the first scenario, I stated the name of the method above as min edit distance, but for convenience I will now specify it as C, as we always use. The situation here is not to use the last character of the first string. Subproblem C parentheses I minus 1 j. We think of it as stripping out the last character of the first string. Because the main goal in the minimum edit distance algorithm is to minimize the differences between two strings, removing a character is costly, and therefore plus 1 is added. And question D, the case here is not to use the last character of the second string. Subproblem C I j minus 1. We think of it as stripping out the last character of the second string. That is, it represents the situation where a character should be added when finding the minimum editing distance. In this case, the addition of a character plus 1 occurs. And in the third scenario, E, situation here, using the last characters of both strings. If last characters are same, C I minus 1 and j minus 1, or if last characters are different, C I minus 1 and j minus 1 plus 1. when we put them all together, we get this recursive formula. This term is condition. This condition, last character same or last characters different. If last characters different, is added 1, or if as 0, otherwise 0. And question 2, I decided to put multiplication cost. We will develop a name. Generally, names such as cost are used. The goal is to minimize this cost, which involves finding the optimal parenthesizations of the matrices in the given chain. For B, question B, this is as I already wrote, CIG, okay, and C, this represents the scenario where the split occurs at the first index k equals to 1, and the cost is minimized by recursively solving the subproblems. And D, similarly for k equals to 2, and for all valid k, the right hand side expression remains the same, representing the optimal splitting scenario. And finally, E, the overall formulation collects all the right hand side functions for different scenario. Aiming to minimize the total cost of matrix multiplication by finding the optimal parenthesization. So this is done. Thank you.